How is everybody? We're here this evening just with Roger and Daz. Michael, as you may have seen from the chat, is still unwell with the virus. Bless him. He popped in to say hello earlier, and he's definitely not well. So we've let him have the evening off, even though he didn't bring a note from his mother. But anyway, we hope you're all well. First of all, a big thank you to those of you who joined us last night for the Starship Flight 11. We had a late night, but it was well worth it because the test Flight 11 went off without a hitch, and all the objectives of the mission were achieved. It was great. I didn't get to bed till nearly 3, but it was well worth doing. And if you were with us last night, we hope you enjoyed it, and thank you for being with us. So tonight on the show, we're going to take a look at Comet 3i Atlas. I know we talked about this quite a bit, but because of the incredible amount of misinformation and downright lies and fantasy going around the internet about this particular interstellar comet, we thought we'd just give you the basic facts so that if you do run into anybody who claims that the comet is an alien spaceship, and they seem to be out there in large numbers, although admittedly most of them on the other side of the pond, as you might imagine. If you do run into anybody who doesn't know the facts, you can give them the facts. It's turned out to be quite an event, quite an astronomical event, because we don't see interstellar visitors very often. This is only the third, hence its name of 3I Atlas, the I standing for interstellar. So it's the third interstellar object to enter the solar system in recent years. There were obviously a lot more. There are probably a lot more that we're not even detecting. And of course, before the first one, which was the famous Oumuamua, try saying that with your teeth out, then, there were obviously lots before that, but we've only really been able to detect them for the last few years. Anyway, I'm rambling. So also tonight, Daz is going to be telling us all about the very first stars in the universe. What do we know about the first generation of stars in the universe and all that sort of stuff, which is actually a lot more interesting than it sounds, because astronomers are on the quest to find this first generation of stars. So Daz is going to tell us all about that. I'd like to say good evening to you all. Hi, Sandra. Hi, Kev. Hi, Kenneth. Hope your weather's good. Hope you're getting some photography in. Who else have we got here? Derek, of course. Derek says, I'm going to put this up on the screen just to embarrass you, Derek. Love playing it. Send the panel home. Thank you for that, sir.
That's warning 1.
Yeah, absolutely. You're on a yellow card again there, Derek. Heidi, nice to drop in. Lovely to see you again. Hope you're well. And who else is here? Jerry's here. Hi, Jerry. And Kev's here.
Heidi. Don't forget Heidi.
Yes. Hi, Heidi. Hi.
Sorry. She won't get that one.
No, she won't. No. Only those of British people of a certain vintage will get that one. So good to see you all. Thank you for being here. Now, actually, we need your help to decide something here on Space Oddities. That is to say that we have noticed that our Tuesday live streams have been just getting longer and longer and longer because there is so much that we want to bring to you. So what we were thinking was this. We were thinking of doing in the future, not quite yet, but soon, 2 live streams per week of an hour each. Now, we've yet to decide what days we can do and all the rest of it. But as an idea, what would you all feel about us going live twice a week? It will make each live stream obviously a lot shorter. We'll do 2 live streams of 1 hour each. And we'd like to know what you, our treasured audience, think about that idea. So in the chat, could you just give us some feedback if you're in favor, or if you think we should just stick to doing 1 live stream, which, we're now up to 2.5 hours on a Tuesday. So if you would like to keep it like that, say so. If you wouldn't mind watching us twice a week, what we would probably do is to have the same sort of content on the same nights. So, for example, we might do Constellation of the Week on the second night, for example. And that way you'll know what's coming up on what night. just to make it consistent. So we'd be very grateful for any comments in the chat about that, because you're our audience and it affects you as much as it does us, and we want to make you happy. So if you have any thoughts about that, would you like us to see going live twice a week instead of just once? Heidi says cool. Sandra says sounds like a good idea. Kenneth says if it suits you better. I think that's great. Thank you you three for that. Any other comments? Jerry, Derek, Kev, what do you think? Derek says I'm happy the way it is. If it's not broke, don't fix it. Thank you for that,
this chap who holds us to the time limit.
Yeah.
With his hourglass.
Yeah.
Oh.
Yeah. Any other comments? Nobody got any opinions?
Ooh.
Please, we need to, because we will base our decision largely on your opinions. So Stuart says, how about 2 90-minute episodes? That's a possibility too, Stuart.
Yeah, don't mind. Yeah, don't mind.
Yeah.
Ooh.
Yes. I hadn't considered that. That's a good idea as well. Thank you, Stuart.
Yes.
Very much. Any other opinions? So we've got 27 people.
Don't mind either way.
Don't mind it either way, says Kev. So is anybody really against the idea? Please tell us if you are against the idea, apart from Derek. So if you're really against the idea, tell us that as well. We just need your feedback. So far the comments have been positive about doing that. So there we are. Anyway, if you could put any other comments in the chat, that would be fantastic. Heidi says no.
No to what? Sorry, Heidi.
Yeah.
Still happy with 2 hours plus, Stuart.
Still happy to, if you have to do 2 nights, I can't do Wednesday or Friday. Okay, thank you, Derek. We will obviously bear that in mind.
Yeah, that's 2 good nights for the show then.
Yeah. Yeah, so it's going to be Wednesday and Fridays, basically.
Yeah.
You don't want to lose Derek.
Yeah.
He's an old friend.
No, we don't want to lose Derek, obviously not.
No.
Obviously not. But I mean, even if you don't catch it live, of course, the video will still be on YouTube, so you're not actually going to miss out. You know, if you can't make it, it'll just be that you won't be there for the full live experience, as it were. Okay, right. Well, thank you all for your comments. If you have any other comments, put them in the chat, please. And Jerry says, like it as it is.
Oh, there it says observatory nights.
That's
even in the clouds.
Yeah.
Paul says he likes the present schedule. So, we're coming into sort of 50-50 territory.
Right. Yeah. So we've got about 50-50 at the moment, which is why we need more comments. We've got 32 people watching at the moment. I can't believe that the rest of you haven't got opinions about this. So please just say so in the chat. Just
if you think about it and put your comments in, and then we'll just check them.
Yeah.
Then we'll take everything into mind.
All right.
So thanks for that.
Yeah, thank you for that. Okay, let's move on. We're going to have a quick look at last night's test flight of Starship. It was the end of an era for Starship because it was the last Block 2 Starship. What does that mean? Well, it's just the version number, really. All the starships of a certain design are referred to as blocks, and the next block logically will be Block 3, and there will be a pause now while SpaceX manufacture the Block 3 starships. The main changes are going to be to the booster, which is going to be an extra 8 meters taller. Can you believe that? With an extra 22% thrust. So it can be more powerful, taller, and should make for more spectacular launches and flights. That's not going to happen until the new year. So there won't be any more test flights until the new year. Normally, when you show these test flights, when we talk about them, we show you the launch, but we thought we'd do something different now. We're going to show you the splashdown of the Starship in the Indian Ocean. fairly close to a buoy that did manage to just about capture it. But this is the last stage of the flight of Test Flight 11, which, as I said, was completely successful for SpaceX, achieving all its mission objectives, including deploying the so-called dumlinks, the dummy Starlink satellites that it deployed 8 of those successfully. Everything else went like clockwork. So here's the last minute or so of last night's test flight. Now, as you can see, the camera's actually mounted on one of the flaps, and the flaps are moving up and down to constantly correct the course of the Starship, which is why the camera keeps moving up and down and round and round as well. But this is coming in over the Indian Ocean, obviously lots of cloud cover. And Starship at this point, as you can see, is moving more or less horizontally. And very soon it's going to fire 3 of its Raptor engines to swing it down into the so-called belly flop maneuver, where it swings to a vertical orientation for landing, and then there will be the landing burn and then the splashdown in the Indian Ocean. Neither the booster nor the Starship were recovered last night. Both of them ended up exploding when they hit the water, but that was expected, because if you put a spaceship that has just gone through 1,000+ degrees into cold water, everything breaks and the remaining fuel ignites, and there it is in the water. You can just see the sea was a bit choppy last night, so but you can see the Starship there. And immediately after that video cuts off, the Starship exploded, but that was fine. It was expected to. Nothing out of the ordinary there. So there we are. That was a great night last night. As I said, thank you for being with us if you were with us. And there we are. So we're going to move on now. We've got all our normal features tonight. We've got the news. We've got Einstein of the week making its return, Constellation of the week, plus the presentations from Daz and myself. So what we'll do, we'll go straight over to the news. Just give me 1 second to sort this out. And not many items in the news this week, but we're going to have a look now. Just give me a second. Okay. Okay, so here is the news on the 14th of October. Very interesting story in the news to start off with. I've called this story "What to Do." Now, what's all this about? This is like something out of science fiction. So what's all this about? Well, in 2032, asteroid 2024 R4 might hit the moon. It's got a 4% chance of doing so, although studies when the asteroid next passes close to the Earth in 2028 may revise that 4% chance upwards or downwards. According to current orbital models, this asteroid measures roughly the length of a passenger jet. It's believed to be composed of rocky material typical of the inner solar system. Its estimated mass is about 300 million kilograms. And if it were ever to hit the moon, the impact would release energy equivalent to around 6.5 megatons of TNT. So that's like a large thermonuclear explosion. The best simulations indicate that it could collide with the lunar surface around December 2032. Most of the remaining orbital solutions miss the moon entirely. So the situation at the moment is one of scientific interest rather than immediate concern. But there's a problem. If the asteroid were to strike, the most likely site would be the moon's near side, because that's where the trajectories that cross the lunar orbit tend to intersect. A near side impact on the moon would be visible from Earth as a brilliant flash of light, whereas a far side impact would be detected only by, obviously, lunar orbiters or seismic instruments. The resulting crater would be about 1 kilometer wide, with a bright ejector pattern spreading for hundreds of kilometers. The collision would eject an estimated 100 million kilograms of dust and rock fragments into space. And therein lies the problem. Some of that material could escape the moon's gravity and enter temporary orbits around the Earth-Moon system, slightly increasing the number of micrometeoroids that might threaten satellites orbiting the Earth, or crewed spacecraft indeed, for several weeks afterwards. None of this debris would be large enough to endanger life on Earth directly, because it would be micrometeoroids which would burn up in the atmosphere. So there's no direct threat to the Earth. So spacecraft operating in the moon's vicinity could be in direct danger from the impact. Satellites and spacecraft close to the Earth could also suffer a heightened risk of micrometeorite damage. Now, obviously, a 4% chance of a lunar impact is low, but it is a potential danger which should not be ignored. Scientists and world leaders, therefore, have 4 years to decide what to do about asteroid 2024 R4. So the question is, why would world leaders become involved? Because one of the proposed solutions to deal with this danger is to nudge the asteroid away from the moon with a nuclear bomb. This would almost certainly necessitate international agreement. Now, the calculations for the effectiveness of doing that, nudging the asteroid off course with a nuclear bomb, well, they're pretty complex, but suffice to say that a 1 megaton nuclear weapon launched no later than a couple of years before the potential impact on the moon would be powerful enough to nudge the asteroid away from the moon sufficiently for it to present no danger. Obviously, the longer we wait, the less likely it is to be successful. So we have to really think about what we're going to do, if anything, about this danger. If we wait for, say, 10 days before the impact on the moon to detonate a nuclear bomb next to the asteroid, we'd almost certainly fail. Obviously, it's not a good idea to actually impact the asteroid to try and blow it up, because almost certainly that will result in lots of fragments heading our way. There are other solutions proposed for this, but, and here's the kicker, lots of researchers say that the most effective way of dealing with this threat is to launch a nuclear missile to nudge this asteroid off course in 2032 so that it doesn't collide with the moon and put spacecraft near the moon at risk, and also heighten the danger of micrometeoroid impacts in Earth orbit, which could, kill a few satellites. The International Space Station, of course, is due to be deorbited before 2030, but there's been talk recently of extending that. So if the ISS is still in orbit, those micrometeoroids could prevent a real threat. So what do you think, guys?
Ooh. Well, we were always talking about these things. What do you think, Rod?
Bruce Willis. We need Bruce Willis back.
Yeah, it's
How did I know you were?
I mean, if we do we think we're got any good idea of what the weight of the mass of this thing, how big it really is? We
what's
any
its
imaging
composition?
of it? Yeah, what's its composition?
Yeah, so it's thought to be a rocky asteroid, which is obviously common in the inner solar system, and it's about 300 million kilograms of mass. So, as I said, that would hit the moon with around 6.5 megatons of TNT, like a nuclear explosion.
I mean, with a nuclear explosion in space, would it be enough to actually nudge it? Because it'd have to be pretty close. Because
yes, it would.
You wouldn't get a shockwave as such, would you?
Well, I ran some simulations of how effective it would be, and although the distance from the asteroid is not known, because we're not sure of the composition and density of the asteroid, so you can't really say exactly how close it would need to be, but all the simulations indicate that a 1 megaton nuclear bomb would stand a very good chance, if we launched it early enough, to nudge this potential threat off course and away from the moon. So,
but also, where do we push it? If we push it away just slightly, where is it going to go next?
Yeah, that's the other thing, isn't it? That we would have to be pretty damn sure that changing its trajectory wouldn't put it on a collision course with the Earth.
Exactly. I mean, if you just don't nudge it enough and it just sort of like misses the moon, where's the next stop? Could be Earth. So
can you
or you might get the gravitation of Venus and Mercury to influence it.
Yeah, true.
It's all theoretical. Of course, if CND still existed, and they'll be moaning about the radiation in the space, but don't worry, there's plenty of that out there already.
Plenty of that out there, yeah. Let me put it another way. Do you think that it's worth doing something about, or should we just ignore it? Because it's only got a 4% chance at the moment of hitting the moon, although that may be revised upwards.
I mean, this is something that's got to be watched closely. And as you said, probably the next pass will give us an indication. But does that mean we're leaving it too late then?
Yeah.
It's I mean, like I said, we see all this Bruce Willis stuff and all that, and we joke about it. But I mean, we know it's sometime the Earth is going to be hit by one of these things.
Yeah.
And we'd rather it be later than sooner. But we've got to be able to prepare. I mean, we've done the impact test with the DART, so which did move an asteroid.
Yeah.
So it's but like I said, is do you wait and just get more information on its trajectory when it could also end up looking too late? Ignoring, I don't think, is actually an option.
No.
You've got to keep an eye on this thing. I mean, we're not going to do up, don't look up. So
no,
it's got to be carefully measured, and if we can get some images of it.
Yeah.
So we can ascertain really what it's like. Because in the past we thought that certain asteroids were rocky, but they've turned out to be just basically big piles of rubble.
Exactly. I said that the next closest approach to the Earth for this asteroid will be in 2028. So in 2028 we'll have hopefully a lot better idea of what we're dealing with. So what do you think, viewers? What do you think of that idea? Would you be against that solution of nudging this asteroid off course with a nuclear bomb? I mean, it's going to be a long way away from the Earth, so obviously detonating a nuclear bomb is not going to present any danger. But I have my doubts that the international community could actually agree on any of this, looking at the state of world politics at the moment. But there we are. Okay.
Interesting. Something to watch out for.
Yeah, absolutely. Yeah. Okay, Daz, I've got a really interesting one for you, actually.
I've just seen the title. Yeah.
Hang on, just let me get through this again. Okay, so the next thing, it turns out that we were talking about ice giants 2 weeks ago. And it turns out that Uranus and Neptune may not be ice giants after all, because a recent study is overturning these long-held assumptions about Uranus and Neptune, suggesting that they may not be ice giants. For decades, astronomers have believed that the two outer planets are composed mostly of icy materials, water, methane, and ammonia, beneath relatively thin atmospheres. However, new computational models challenge that view, showing that the internal structures of Uranus and Neptune could be dominated by rocky and metallic elements rather than vast layers of ice. So what's happened is that researchers created thousands of randomized planetary models that matched all known observational constraints, including each planet's gravitational field, magnetic properties, and density. The surprising result was that many valid models required significantly less ice and more rock for those planets, implying that both planets might be closer in comparison to sort of scaled down gas giants like Jupiter and Saturn, instead of being uniquely ice rich. The findings also highlight how little direct data scientists possess. Well, we know this, of course, because the last spacecraft to visit Uranus and Neptune was Voyager 2. Since then, our understanding of their interiors has relied entirely on remote observations and theoretical modeling. We haven't got any new data about these planets. If these new interpretations hold true, they could force a re-evaluation of planetary formation theories, not just for the outer solar system, but also for the thousands of exoplanets that appear similar in size and mass to Neptune and Uranus. The term ice giant may therefore be misleading, obscuring a more complex and rocky reality beneath their clouds. The researchers emphasize that future missions to Uranus and Neptune, equipped with orbiters and atmospheric probes, are essential to confirm these conclusions and better understand the diversity of planets both within and beyond our solar system. So there you are, Daz. They may not be ice giants after all.
Yeah, I'm so glad I wasted my time.
Yeah, Daz,
Oh dear.
Daz has actually done a presentation about the differences between gas giants and ice giants, and whoops. So I don't think we'll be bringing you that somehow, viewers. But listen, this is only theoretical modelling. It may or may not represent reality, but it's you know it's striking that the best fit for a lot of the simulations they did in putting all these variables about the magnetic field and the density and everything else came up with the idea that actually there's a lot more rock there than we thought. So so there we are.
Yeah,
it's a shame.
Yeah, I mean, Deep Burrito says so. Basically, slushy planets.
Yeah, basically. I mean, if you think about it, Deep Burrito, I mean, Jupiter is basically a slushy planet because it's got that thick layer of liquid metallic hydrogen, and the core is, as we now know from Juno, quite slushy. So yeah, absolutely. So so I just thought I'd cheer you up with that one, Daz.
So if they're slushy and they're blue, are they sort of like tutti frutti flavour then?
Not known.
Well, considering we're supposed to have rotten eggs, aren't we? On the smell of rotten eggs on Uranus.
Okay, so moving on. I'm going to show you a picture. You won't have a clue what this is unless you know. So I'm going to have to explain this to you because it's not apparent. Look at this. So what is this? Well, this is the first, we think, the first direct image of two supermassive black holes orbiting each other. This is a major breakthrough in observational astrophysics. This is a system known as OJ287. It's about 5 billion light years from the Earth. And it's always had sort of periodic bursts of energy that scientists have been really intrigued to know what causes that. And this image on the right here shows two distinct sources of radio emission interpreted as the twin cores of these supermassive black holes. The larger of the pair has an estimated mass of about 18 billion solar masses, 18 billion times that of the sun. The smaller one also produces a jet of energetic particles. Now, the diagram on the left shows you the two black holes, the larger one in the center, and you can see the other one. And the lines are representing the angle of the jets from these black holes. And the smaller jet has a slight wobble or twisting pattern, which appears to be caused by its orbital motion around the larger object. This obviously supports the idea that this is a binary supermassive black hole. To obtain this extraordinary level of detail, researchers combined data from a network of radio telescopes across the Earth and from the Radio Astron Space Telescope, whose orbit extends nearly halfway to the Moon. This enormous baseline provides the angular resolution necessary to distinguish structures only a few light years apart at such a distant location, 5 billion light years away. That from 5 billion light years away, when you're looking at features only a few light years across, that is an amazing image on the right there. Although the findings fit predictions made for this long-standing thought that it is a supermassive black hole binary, the team obviously is very cautious about this because, you know, the possibility is that the features are due to a single black hole producing a complex or bent jet rather than two separate sources. Further imaging over the coming years especially if the smaller black hole's orbital waggling, if you like, can be tracked, will be crucial for confirming it. But if verified, the result would represent the first visual confirmation of a binary supermassive black hole system, offering direct insight into how galaxies merge and how such pairs evolve towards eventual coalescence, producing, as we know, the powerful gravitational wave events now detected by LIGO, Virgo, and CAGRA. So, this is exciting. We could be looking at the first image of a binary supermassive black hole. Obviously, we're pretty sure such things exist because, for a start, when you have two galaxies merging, the supermassive black holes at the center of either gradually come together and start orbiting around each other, eventually merging. Although, of course, we have that final parsec problem, which suggests that they never actually merge, but that's another story. So you could be looking at the first image of a binary supermassive black hole. Exciting stuff, I think, anyway.
Yeah.
Yeah. Okay.
And I missed it because I was dealing with something on the other screen. Was that an event horizon image, Andy?
No, this is radio images.
Oh, okay.
Well, it's obviously event horizon telescopes, radio, but the Radio Astron Observatory, which is halfway to the moon, provides a baseline using interferometry with telescopes on Earth. And it's that long baseline halfway to the moon that's enabled them to get this exquisite resolution. The Event Horizon Telescope couldn't do this because the baselines are, restricted to those on the Earth, which can only be, a few thousand miles apart. But when you've got a telescope halfway to the moon, you can link it with one or more on the Earth and form one giant radio telescope, which is what they've used to get this exquisite resolution. Amazing stuff. Okay, and lastly in the news, now you've heard of this elusive planet X, yes? This ninth planet, or if you want to call it that, planet 9, which is sometimes called planet X. But have you heard of planet Y? Now, this is a new idea. It's not yet confirmed, but the authors of the paper about this argue that it offers a promising explanation for certain orbital anomalies seen in distant solar system objects. So the impetus for all this comes from observations of about 50 Kuiper belt objects, which henceforth we'll abbreviate to KBOs. They show a consistent tilt of roughly 15 degrees relative to the orbital plane of the known planets. And the authors suggest that such a tilt is best explained by the gravitational influence of an unseen body. Under their model, planet Y would be a rocky world with a mass somewhere between that of Mercury and the Earth. Now, importantly, the team estimates that planet Y would lie between 100 and 200 astronomical units from the Sun. This is much closer than what's proposed for planet 9, which, various estimates, but sometimes the estimates are about 400 astronomical units for planet 9. So because it's nearer and because it's smaller, it would be obviously much fainter and harder to detect directly, especially if its orbital plane is tilted up by 10 degrees relative to the known planetary plane. Now, there's been some criticism of this hypothesis. People caution that the sample size of 50 Kuiper belt objects is a limited sample, which makes statistical claims weaker, obviously. But some astronomers regard the planet Y idea as intriguing, but not yet compelling. So they need to do additional measurements of Kuiper belt objects. And obviously, ideally, they want to try and spot the object itself. Now, the Vera C. Rubin Observatory, which is starting its observing run towards the end of this year, may help resolve this question because it will have the sensitivity to detect lots more Kuiper belt objects, which they can then use to see if they too have this tilt of 15 degrees relative to the ecliptic, and if indeed they fall within the telescope's field of view. So if nothing is found in the expected region during that time, the hypothesis may be abandoned altogether. But it is intriguing that we might have not one new planet in the solar system, but possibly two. So that's intriguing stuff. Yeah. So there we are.
So is you wait for one and two come along.
Exactly.
Yes.
Exactly. So that is the news for this evening on Space Oddities. More next week, obviously.
Ooh.
Yeah.
Gosh.
Intriguing stuff. So let us move on. And in time-honored tradition, we like to give Roger something to do on this show. And he does it so well that we just have to go back for another dose. So we're going to go over to Roger now. And with his look at what's in the night sky, and of course the viewers gallery.
A gallery,
yeah,
and a very good one we've got too, especially this week.
Great.
Right. Okay. So we're heading on towards the latter part of October, but the week after this one, the clocks will be going back, so we get an extra hour of darkness. So we've got even longer to look at the cloudy night skies. But there we are. So onwards and upwards. So we're heading back from the last quarter over to a new moon following on Monday. So things will be improving for those that like to get some night sky shots. But looking at the night sky for the middle of the week coming up, we've still got some of the summer triangle up above the horizon, although it is rapidly diminishing now. But we have got Saturn quite nicely positioned in the southern skies, looking very nice, and Andromeda above. But as you can see, we are now getting more and more of the winter constellations coming through, with Taurus and Orion coming up through very nicely. And not far off Orion rising, we've also got Jupiter coming up as well. So when you get one planet coming up, that's you get two coming, right? Yeah. But in the morning, but we've also got, following on from Orion, we've also got all the other constellations coming up through, and just before sunrise, we've got Venus appearing as well. So got some quite nice bright planets coming up through the night sky and the morning as well. So we also have got the Orionid meteor shower.
Oh, I like coming up.
Yeah, so that's quite good. So this was all due to Halley's Comet, and that's the reason why we've got that. Although we get the Orionids every year as opposed to every 76 years for Halley's Comet. So that's a shame. So we've coming through, radiating apparently from Betelgeuse. So it better not explode just too soon then, otherwise we'll get confused. Okay, so we are coming up through the period from between the 20th and the 23rd of October. Although if you look at the graphic on the right, you wouldn't want to use that calendar very well, because it's got quite a few 22nds and 23rds on there. So roll on better AI on that one, and we only go to the 23rd of October, even though it's sort of got like 33 days on there. But if we're in the northern hemisphere, which we absolutely are, Orion will rise about 10 o'clock, and then the activity will be able to be a bit more obvious from there, with up to 20 meteors per hour under ideal conditions. That's what we all say. We live in hope. So the 21st with Orbos will also be a new moon. So it's obviously a perfect time for going out and looking at those lovely meteors going through the skies. So with the following weekend coming up after that, we've got darker skies. So it might go on for a little bit longer, but I think we might have missed the majority of it by that weekend anyway. So hopefully we might get to see something. So we've also got the Moon and Jupiter coming up through, and we've also got Mercury and Mars coming up through as well. So that's all to be during the pre-dawn skies. So keep an eye out for that. Mars will be minus 0.3, and Mercury at 0.3, and Mars at plus 1.7. So get your binoculars ready.
Yeah, indeed.
That could be quite good. So we've also got Ceres coming up for opposition as well. Even though it is only magnitude 7.6, it will be okay to be looking at that with a pair of binoculars or a telescope. And obviously, if you like to photograph it, you'll be able to see, if you get a good run of nights, see how it moves against the background of stars as well. Okay, so we've got the 10th of October, just 1 degree of the moon between the Pleiades as well. And then we've also going through that. Right, okay, so what else have we got through later in the week or the month? We've got Mercury reaching the greatest elongation, so it'll be the highest in the western horizon after sunset. So it might be visible for up to 45 minutes after sunset, providing you've got a good horizon to be able to see it. And if you've not seen Mercury, it's worth a tick. So have a look for that. Right. And we've also got Comet Lemon, which will be becoming more and more visible through the latter parts of October. So at the moment, it's coming through Canes Venatici. It'll be going through Bootes, and then heading on down through there, which is down below. Yes. So yes, here is a previous picture of it. I would take the magnitudes with a pinch of salt. I mean, if it goes down to magnitude 1.2, that would be absolutely awesome. But it's you know, very debatable. So as you can see, as we get through the month of October, it will become higher and higher through the night sky, although the constellations will be getting a bit lower down in relation to where it is. But in relation to 7:30 to 8 o'clock, that's roughly where it will be at that point in the night sky. So there is a very good chance of you being able to get that. So pictures to the gallery, please. Be much appreciated. And talking of the gallery, here we go. So we've got a few from our regulars, got a few from Tom McCrory, who's our one of our resident panelists, and this is the elephant's trunk with 27 hours of time spent, because he likes to do extreme long exposure.
That's amazing.
So there we go.
A lot of detail in there.
Yeah, well, that's what happens when you spend 27 hours of your life taking pictures.
He's not
even retired. That's the thing, you know. So where?
Yeah, I mean, how many clear skies? How many nights of clear skies do you get in Scotland?
Yeah, true.
I call foul.
Yeah,
Ian would say hardly any.
Yeah. Are you sure he's not in somewhere else doing this? And then he's also got M51, which was using in a one-shot color. He's only cut back to 12 hours on this one. So here we go.
Oh wow, that's beautiful.
That's stunning.
Yeah, he's managed to get all the dust and stuff around the outside of it all. So
yeah,
just shows you what happens when you get interacting galaxies colliding.
That is stunning.
Very good.
That is stunning. Well done, Tom.
Yeah, you can tell he's done that with a Newtonian with the star spikes.
Yeah.
Yeah.
But you've also got the galaxy down towards the sort of 8 o'clock position over on the left-hand side.
Yeah, little tiny galaxy. Yeah.
Little tiny edge-on galaxy there. Very nice.
Yeah.
Well done, Tom. And then we've got
Bode's galaxy, is it?
No, nowhere near.
Looks like
Not
it.
yet.
No, I was going to say it's nowhere near, but it looks like it.
No, no, it doesn't.
All right, it doesn't then.
No. And then we've got the first objects, the Crab Nebula. And this
Ah,
was using a one-shot color camera, which he only spent 8 hours of. So, you know, just one night. But this is what he's managed to do. A great sort of wide shot of it. And he's got lots of details in the
Certainly has.
in the spindles there of all that gas.
But the shape's definitely changed, hasn't it, over the years? You can see it.
Yeah, it's quite interesting right from the very early days of photography to how that is. It's changed quite considerably.
Yeah, it has.
Yeah.
Well done.
So, well done. And then Tom has also got SH2174.
Does he never
Valentine?
Does he never?
No, he doesn't. No. With all these things, he must be doing it in the daylight, I think.
Yeah, he must be.
So the Valentine's Rose Nebula. Now this is a new one to me. So it's
like 14. Blimey.
Yeah. So it's only 12 hours, and look at that. Oh, quite interesting. Quite an interesting design. That. Very good. And then, just to top it off, we've got one from Jerry, the lobster claw. And this is what he's put for that. Well done.
Wow, well done, Jerry. That's beautiful.
Yeah, nice to see one of that. We usually see it in the opposite orientation, but who says which way is up in space?
Actually, there is no right way up.
No.
Absolutely. Well done, Jerry. Lovely image. It's all going well. Now, this is an interesting one from Kevin Earp, just showing you the different sizes of the planets. I should have put this one on DIN, taken on the same night. So let me just get rid of the text a minute. Oh, hang on. Oh, didn't get there. So it just gives you a comparison of how small Neptune is when you try to take a picture of it in relationship to Saturn, which isn't as big as Jupiter. So it can be quite a challenge to get a disk sometimes. It just depends on what your focal length is on your telescope. But well done, Kevin, for giving us that.
It's very small though. It says the diameter only 2.5 inches. So
yeah,
done well to capture that.
It is.
That
Absolutely. Right. Okay. And oh dear.
Oh,
Shall we move on? Shall we move on?
No.
Now this was just a wide angle camera shot at a local tourist spot, but that was just illumination from the moon, the last quarter moon. But unfortunately, with the Milky Way core setting a couple of hours earlier, we've only got the remnants of what was left of the Milky Way there that was visible with all the moon glow in the night sky. But still made an interesting picture.
What folly was that, Roger?
This is King Alfred's Tower, which is adjacent to the National Trust place at Stour Head.
Oh, okay. It's a lovely place, isn't it?
Yeah, it's a 3-sided tower. So you can so there's a spiral staircase which goes all the way up. So if you go to the top, you can overlook Somerset and Wiltshire as well.
Wow.
Because it's sort of on the Somerset-Wiltshire border where this is anyway. So you can have a damn good, it's almost like being on a hill where a TV transmitter is. You can sort of see from miles and miles around from that area.
Yeah. Lovely.
Right.
Lovely.
Okay, and we've got some more moon pictures here that I've managed to do.
Beautiful.
Lovely.
Yeah, this is just stacked in using sharp cap stacking tools, so it saves a lot of faffing about with the processing afterwards. So that's what that was all about. And just in case you got excited over that one, we've got these, which I've also done, which are closer up views of some of the details there.
It's gorgeous.
And we've got some quite good details on the left-hand side of Tycho there.
Yeah.
Lovely.
Which gives out quite a lot of rays as well. So there's some quite interesting pictures of the rays coming out, which would also be similar to this forthcoming meteor strike. Might also might happen. So this would be a similar thing, but on a much smaller scale to what these are.
I mean, from your point of view, Roger, you must be thinking that asteroid is going to hit the moon, so that you get something new to photograph.
Yeah, I mean, I did see the comments on the panel there from the viewers there saying what my pictures are going to come out like when you get a strike.
Do a time lapse.
Yeah, probably.
Yeah.
Okay. Right. So onwards and upwards, and this was an interesting one. I did last year, going through some of my pictures, use a different filter on my one-shot color camera, and I pointed it at the Orion Nebula, and this was what I got.
Oh, that's lovely.
It gives you a different color perspective of what we usually get, but this is just using the ultimate, so it just cuts out some of the narrowband sections of the spectrum to give you this aspect of it. So might be worth trying that with another color filter, an ordinary 3-color camera, to see what effects that can do. So maybe next time I'll try that. And we've also got some pictures from Iceland, from Lou's visit.
Oh yes,
I managed.
Sorry, I did to say that Lou's not with us tonight because he's in Iceland, and here's the proof. Wow.
Fortunately, he managed to get some clear skies from his cloudy, wet Iceland trip, and he's still there. And he managed to get this. This was traveling out about 30 miles from Reykjavik, and he's managed to get some fantastic aurora shots. So he's well chuffed with that. I think it'd be a disappointment to go there and not get it. And here's one that he took with his Galaxy S25 Ultra. And just another view of the aurora coming through. So
that's lovely.
All well and good. So that's what we've had for the gallery this week. So it's been quite a wide variety of images. So all's well and good.
Yeah, absolutely. Fantastic stuff. So
before we go any further, can I just Kev says here, Kev Earp, says he's posted 3 images but didn't receive receipts for these. This has happened before. He's asking, is there a problem with the emails?
Well, I haven't seen. I've only seen the one that he did of the Jupiter and Saturn. I don't know what's happening.
Funny. We actually had to investigate this end of last week because Tom had sent some images in. He had a receipt that they'd been received, but then he got other messages saying that the email hadn't been delivered, but they did turn up in the inbox. So I've looked into it. Honestly, Kev, I can't see anything wrong with the email system, but I will investigate further. Very sorry for the inconvenience. Please don't let that stop you sending the images in. So tomorrow I will take it up with our provider and see whether we can work out what's going on. But everything looks normal because I've sent test messages to the inbox and there hasn't been any problem. So something is going on, I think, but I really can't put my finger on it at the moment. But I will investigate further tomorrow, I promise. So really sorry about that. Obviously, we don't want to inconvenience you. So there we are.
Well, something good for next week then. Hopefully.
Yeah, definitely. Yeah, hopefully. Yes, we could just ask you to send them in again, Kev. And if you don't get any receipt that they've been received, could you just let us know by sending an email to info@spaceoddities.space, info@spaceoddities.space, just to let us know that you had no confirmation of receipt, which is automatic, of course. So if you could do that for us, we'd be very grateful, because that would really help us track the problem down if that's the case. And thank you. Okay, so if you would like to send your images into our weekly gallery, because we do love looking at them and we think our viewers do like looking at them as well, attach an image to an email, 1 image per email, please, and just mail it to gallery@spaceoddities.space. That's gallery@spaceoddities.space. Before we go any further, I'd like to say a big warm welcome to our quite frankly bewildering number of new viewers that we seem to have this evening. You are all very welcome. We hope you enjoy yourself here at Space Oddities. We hope you will consider subscribing to the channel. And at the very least, if you could leave a like and a comment on the video on YouTube, that'd be great as well. But you're all very welcome. We're absolutely overwhelmed to see how many new viewers we appear to have this evening. I hope it's not a technical fault, but we do appear to have a large number of people with us this evening. So thank you. You're most welcome. Welcome to Space Oddities. This is what we do. As you can see, we do it every Tuesday and 8 p.m. UK time. And we just tell you all about the universe. And speaking of which, if you would like to support the channel, then you can do so in a number of ways. You can click the super chat icon underneath the chat window, which is the one with the $ on it, where you can make a donation directly to Space Oddities. Every bit of money we receive goes towards keeping the channel running, because we have bills to pay like everybody else. So, we're not pocketing anything. It all goes towards the bills that we have to pay. You can also support us by buying us a coffee. And you can either scan the QR code on the screen, or you can click the link that should have just appeared in the chat. That will take you to the Buy Me a Coffee page, where you can buy some caffeine, which we need to keep us going, and all these long hours we spend preparing this stuff for you. So buy us a coffee. Alternatively, of course, you can go to the Space Oddities shop, and we have a selection of hoodies and T-shirts available. And the merchandise is there. Again, you can scan the QR code, or you can click the link in the chat, which will take you to our shop, where you can buy your Space Oddities T-shirts and wonderful hoodies. Winter's drawing in, temperatures are dropping all over the place, and you need something to keep you warm. So what better than a Space Oddities hoodie? You can also join our Patreon page, which is very simply patreon.com/Space Oddities. That's patreon.com/Space Oddities. And the benefits that you get there, well, you get all the presentations that we deliver on a Tuesday. Tonight's presentations are already there. And you also get lots of Space Oddities videos that we've created. Don't forget, we've got about 600 videos that we've created all about the universe on the channel. Lots of those are on the Patreon page. You can chat with us there. You can chat with other viewers. We're trying to get a community going on Patreon. So just for a few pounds every month, just for the price of a few cups of coffee, you can join the Patreon community, and we'd love to see you over there. So just one more time, that's patreon.com/Space Oddities. And at this point, we're going to take a break for a word from our sponsor. If I can just get this up. This video is sponsored by Picastro. It's like Instagram for space nerds. Okay, so that's actually a creation of Tom. Picastro is it's like, as it says, it's like Instagram for space nerds, where you can join the astrophotography community. You've already seen the quality of images that Tom can produce when he's got enough days to do it, and it's a wonderful application where you can upload your images, interact with other astrophotographers. No image compression, so everything appears on the site as you intended. So sign up for Picastro. So there we are, and we're glad to be associated with Tom, because it's a wonderful app. If you're at all interested in astrophotography, you can download it, of course, from the Android and Apple stores, completely free, of course. So, okay, so we're going to move on now. We come to the main feature for tonight, if you like, the top billing, which is all about Comet 3i Atlas. Now, as I said at the top of the show, there's so much information about this comet on the internet. It's getting progressively more bizarre. It started off by, but basically it was renowned astrophysicist Avi Loeb who started all this off by just suggesting that we cannot rule out the possibility that the comet is in fact an alien spacecraft. And in that he's absolutely right, because you can never rule anything out 100%. But unfortunately that snowballed from there, and he made some further comments which exacerbated it. So now the comet is definitely an alien spaceship. There's a Comet Lemon is a probe launched by the mothership that is Comet 3i Atlas. Another one I saw is Jesus coming back to Earth to do the rapture, and all sorts of lunacy has been going around the internet. Lots of misinformation, thousands of videos on YouTube, just basically lying. It's all AI generated clickbait. So we thought tonight we'd put the record straight and tell you just the facts about the comet, what we know. So we're going to now have a look at that. So just give me 1 second to pop this up on the screen for you. And we're going to have a look at what we know about Comet 3i Atlas. So first of all, what is it? Let's start with the very basics. Yes, it's a comet. We know that. It's an interstellar comet. It's come from another star system. And the 3i part of its name, it means it's the third interstellar, hence the I object that we've so far detected traveling through the solar system. It's a remarkable discovery. The Atlas part of it comes from the Atlas telescope array in Chile, where it was discovered, and there's a picture of the Atlas array in Chile there. It was spotted on the 1st of July 2025, and it's the third interstellar visitor, if you like, after Oumuamua and Comet Borisov, which we've seen in recent years. And in case you're wondering what ATLAS stands for, it's the Asteroid Terrestrial Impact Last Alert System, because of course it is. And this was the array there you can see on the right that first detected it in July. Now, we know that this is an interstellar comet because of a few things. Firstly, the orbits of comets in the solar system are elliptical, as shown in the diagram at the top. But 3i Atlas has a very, very, very different trajectory. And it's a hyperbolic orbit. And you can see from this that it's a very different type of orbit to the orbits we see in comets that originate within the solar system, or the Oort cloud brackets, if it exists. It's not gravitationally tied to our sun. And in fact, it's really sad. It's moving far too fast to be captured by the sun's gravity. So it's here today, gone tomorrow. It will leave the solar system and on to its next destination, wherever that may be. It's not going to get any closer than 270 million kilometers from the Earth. So let's kill that bit of misinformation. It's not heading for our planet. It's not going to collide with the planet. We're perfectly safe from this comet. Absolutely no threat whatsoever, because it's not, as I said, going to be closer than 270 million kilometers. The closest approach to the sun is going to happen at the end of this month, on the 29th, inside the orbit of Mars. We saw last week the amazing images that the Martian rover and European spacecraft orbiting Mars have managed to get with the comet. A little bit indistinct, but as we said, the rover and the orbiting spacecraft around Mars are not designed to take photographs of objects like comets. So the fact that we got anything is quite remarkable. And as I said, it's traveling at an amazing speed, 68 kilometers per second. This is one of the fastest visitors ever recorded. So it's not going to get captured by the sun's gravity. It's moving far too fast for that. As for its size and shape, well, estimates vary, but between 0.3 and 5.6 kilometers across, the size of the nucleus. but most likely, most astronomers seem to be agreeing now that it's actually under 1 kilometer across in size. The coma, this cloud of gas and dust surrounding the comet, extends for 100,000 kilometers around the comet. And the Hubble Space Telescope has captured stunning images revealing it's sort of got a distinctive teardrop-shaped coma, and which obviously could be seen right across the solar system. This is chemically very interesting. It's very rich in carbon dioxide, unusually rich in carbon dioxide, which is what is distinguishing it from typical solar system comets. This is how we know that another way we know it isn't a solar system comet. It's got exotic elements, cyanide gas. Well, that's not unusual in comets. You may know the story that with the apparition of Halley's Comet in 1910, scientists said that they detected cyanide on the comet. The world panicked, thinking that we were going to pass through its tail and everybody on the Earth was going to get gassed by the cyanide, which of course didn't happen. But a lot of people made money out of selling cyanide gas masks around the time of the apparition in 1910. So there's no danger from that at all. But it also has atomic nickel vapor. And again, this is not unknown in comets, but the actual ratio of nickel to iron is actually quite high. So this again marks it out as something different from what we would normally expect to see in the solar system. It's the chemical fingerprint of an alien star system, not our own. It's got lots of water ice, of course, water vapor, carbon monoxide and carbonyl sulfide, key ingredients from wherever it was born. And we mentioned last week or the week before that astronomers using data from Europe's Gaia probe have managed to trace its path back around the galaxy, and they believe that it's had flybys like it's flying by our sun of around 62 stars, which they're fairly certain about. It could be as high as 93. So this thing is billions of years old, and for the last 10 million years, it's actually encountered quite a few stars on its journey. It's not come particularly close to any of them because there's no indication that ultraviolet light from a star has altered it chemically in any way. So this is sort of pristine material from billions of years ago. This is why it's so interesting. And at the moment, it started doing this, 3 or 4 days ago, it was announced that it's outgassing water with the pressure of a fire hose. This is highly unusual behavior, suggesting volatile rich composition, maybe even some organics thrown in there as well. But this outgassing of massive quantities of water is unusual, and we don't see it in solar system comets as much. And this suggests that the comet actually originally formed in a cold, distant region of its original star system, and it's been preserved in deep freeze for billions of years. It's also generated something that's quite unusual. It's generated a tail facing forward towards the sun. Now, again, this is not unknown in comets. If anybody remembers Comet Aero and Roland in 1957, I don't personally remember it, of course, but that had what looked like a spike on the front of it, which was a tail, which is actually called the anti-tail, pointing at the sun. So this is it's actually not that difficult to explain. But what happens is because the comet pushes out large dust grains, which are too heavy and too dense to be swept away towards the back of the comet by solar radiation away from the sun. So these dust grains remain at the front of the sun. And that's where we get these this anti-tail from. As you can see, hopefully in these images, that there is a lot of dust in front of the comet, which is called the anti-tail. Although it's not that prominent, but it is there nonetheless. Now, what about its age and origin? Well, its estimated age is 7.6 billion years, 3 billion years older than our solar system. Its gravitational interactions with giant planets or passing stars likely flung it from its home system into the interstellar void. This again is not unusual, as we understand it. Whole planets could be ejected from their star systems by interactions with other planets. So star systems, especially in their youth, can be actually quite volatile, with objects flying about all over the place. But this was an ejection from its star system, and it's been wandering the galaxy for 7.6 billion years. And we think that it came from either the thin or the thick disk regions of the galaxy. So not from the galactic halo, for example, but from the actual disk of the galaxy is where it's been wandering through. Yet to be conclusively demonstrated, but we think that's where it was formed, somewhere in the disk of the Milky Way. And it's just pure chance that it's wandered into our solar system. Lots of international efforts. This is a truly international collaboration of astronomers, as astronomy is these days. And we've had the Hubble Space Telescope looking at it, which captured detailed images of the nucleus. As we saw, orbiting spacecraft around Mars, and the Perseverance Mars rover managed to image it. The James Webb Space Telescope has provided the infrared spectroscopy, revealing this unusual carbon dioxide-rich composition. And the observatories Swift and Sphere-X have also done multi-wavelength observations tracking its activity and composition. So from now, the comet is going to be temporarily unobservable as it goes behind the sun as seen from the Earth, but it's going to re-emerge in December, where there will be a lot more studies performed on it. Of course, it will be further away from the sun then, but there will be a massive international effort in December to find out more about this really intriguing orbit. Why does this comet matter so much? Well, first of all, it provides rare direct evidence about how planetary systems form around distant stars, a window into alien worlds we can't yet visit. And I like the optimism of the word "yet" there. Excuse me. We can do a comparative analysis comparing this comet to Oumuamua and carbon monoxide-rich comet Borisov, the second interstellar visitor in 2019, and now 3I Atlas. So it's quite interesting that Borisov was carbon monoxide rich and 3I Atlas is carbon dioxide rich, indicating different origins for both of those comets. So very interesting to do an analysis when all the data's in. Excuse me. The comet really does challenge existing models of cometary activity. We've never seen anything quite like this before. And it does reveal the remarkable diversity, I'm so sorry, created in different stellar environments. So it's an indication of just how diverse these objects can be. Even though we know it's a comet, it's not like anything we've seen before. But you've got to remember, it would be very strange indeed if it did resemble our solar system comets, because it's formed in a completely different environment. So you would naturally expect this comet to be different from anything that we have in the solar system. So behind the sun now pops out again in December. In March, it crosses Jupiter's orbit. And beyond, well, it's going to continue out of the solar system, and we will lose it forever, and we will never see it again. And who knows how many billions of years in the future this comet has got ahead of it. Who knows how many more star systems it's going to visit. So it's quite a romantic thing, I think, this comet. It's a reminder that our solar system is just a little tiny corner of the universe. And with a bit of luck, we will get more visitors in the near future. Europe has suggested permanently stationing a spacecraft at either L1 or L2 to have it sitting there just waiting for another interstellar visitor, which it can then go and intercept. Interesting idea. It would be wonderful to have something on standby to be sent towards any interstellar visitor, if it's, you know, the right distance and on the right trajectory, of course. But it's an interesting idea and wouldn't be too expensive to to do. So this is all just a reminder of the incredible diversity and environments of our galaxy. So just in a nutshell, what makes this comet so unusual? First of all, the polarization. Sunlight reflected from the comet is polarized in a way that we haven't seen from a comet. That's telling us something about its composition, but and surface features, but we don't know what that is yet. The comet entered the solar system along the plane of the major planets, the ecliptic, but this is by chance. It's unusual, but it's a coincidence, and obviously that's led to speculation that it's been sent here by aliens to visit Jupiter and Mars, and etc., etc. But it's just pure chance. I mean, things happen by pure chance, don't they? Just so happened that its trajectory is along the plane of the solar system. It's ejecting these huge amounts of water with the pressure of a fire hose, which is indicative of its formation and composition. It's got this high carbon dioxide to water ratio, higher than any solar system comet ever seen. And that's telling us a lot about the environment it formed in, probably beyond the carbon dioxide frost line of its host system. So way out in the outer reaches of a star system is probably where this comet formed. Last week it did something a little bit bizarre. It changed its color. It was sort of whitish before. Now it's turning green, indicating chemical changes as the comet approaches the sun. And we've never seen this before. We've never seen a comet change color in this way. Again, indicative of what's going on the surface and its composition. It hasn't developed a long tail. We saw Roger's image of Comet Lemon earlier, that lovely long tail. So it hasn't developed a long tail, which is a little bit strange, but it has generated an anti-tail, which is telling us something about its dust composition and the size of its dust grains. It's moving at an incredible speed, too fast for the sun's gravity to capture it. It is a temporary visitor. It's not going to hang around. And then just to finish, I just thought this, just to show you how bad this misinformation has got about this comet on the internet. On the left, some video titles that I found on YouTube, and it's only a few of them. There are thousands, and a lot of them are being AI generated as well. James Webb just caught 3i Atlas moving faster than light. Voyager just caught 3i Atlas moving faster than the speed of light. So alien spacecraft 3i Atlas could attack Earth in 2025, scientists warn. 3i Atlas fleet to harm or to save us. 3i Atlas loaded with toxic material. Michio Kaku, well, I don't really want to talk about him because it will just make me a bit angry. But he's, he's an astrophysicist who does remarkable work, but he's incredibly good at self-promotion. And he loves stirring the pot, absolutely adores it. And he's now claiming that 9 hidden objects have been discovered escorting the comet. All of this is complete nonsense, of course. Nothing can travel faster than light. It's the comet's not loaded with toxic material. It contains cyanide on its surface, but that's it. And even if its tail were made completely of cyanide, and even if the Earth passed through the tail, the tail will be so tenuous that you might get 1 molecule per 1,000 square miles or something ridiculous like that. So that's ridiculous. It's not going to attack the Earth. There's no fleet and so on. But there are literally thousands of these videos being churned out. And a lot of people are watching them. It must be said they are getting really good numbers of views, much better than we get, which is a bit depressing, really, because we do have those facts about the universe. No, some of these videos are getting up to nearly 1 million views on YouTube. I was having a look. I was absolutely shocked, and it's just a shame that people don't study the science, as I've just been talking to you about, and will prefer to watch sensationalist nonsense. But we persevere here at Space Oddities. We do what we can, our own little oasis of truth. And there we are. So I hope you enjoyed that. That's all about the comet. We hope you're armed now with the facts to fend off anybody coming up with this misinformation. And there you are. So that's Comet 3i Atlas. We will no doubt talk about it again in December when it reappears from behind the sun, and we will keep you posted if there's anything new that we learn about it before then. So there we are. So that's Comet 3i Atlas. So does it make you depressed, Roger and Daz, that we don't get the views where people just make up nonsense and it gets potentially up to 1 million or more views? I think it's really, but
well, it is, as you said, it is depressing. But anything that mentions aliens on YouTube is going to get a huge watching. And this is why people produce these things. They can talk nonsense, they can make things up, and people will watch it. I just hope they don't believe it. I mean, Bossman says here, thanks for explaining. I've seen some of these titles myself.
Yeah.
And it is very, very sad.
Yes.
But yeah, I mean, each to their own at the end of the day. But just don't fall for the hype and actually start believing these things.
Yeah. It's all clickbait.
Yeah, but it's so easy to do with AI these days. You can set up a YouTube channel with AI. You can get AI to create a YouTube channel. You can get AI to create videos. You don't have to do anything. You can just tell it, make up some nonsense about the comet, whatever you fancy, and people will watch it in their droves. It's I don't understand it myself. There's a psychology thesis in there somewhere. I'm telling you that much. So there we are. All right, then. What we're going to do now is we're going to go over to Daz. And Daz is going to tell us all about the universe's first stars, which obviously is a subject of intense astronomical research, because we need to find these first stars because it's important. We need to know about the early days of the universe. So I hope, the Deep Burrito says woo-woo levels are off the charts here in LA. I can imagine, Deep Burrito. I can imagine. Shelley, hi Shelley, says can't fix stupid, and I think that sums it up in a nutshell. Thank you, Shelley. Yes, yeah. So there we are. Right then, Daz. I'll leave you in the capable hands of Daz, and who's going to tell us all about his first stars.
Right. Basically, what this is just going to be talking about is what we've. This is basically the history of what we have thought about how the first populations, 3 stars, as Ian's just popped in the chat. How we think that they've evolved and what they've done. And of course, we're talking about the beginning of the universe, just after the Big Bang. And basically, the James Webb especially has its new evidence, its new imaging, has basically had to change our thinking of the theory of what these basically stars are, how they formed, and things like that. Now, in this, I'm going to be touching on a few phrases which are a bit nerdy. If you understand them all well and good, I will sort of like explain a little bit about them, but I'm not going to go into the deep stuff. Also, just more, hopefully next week, I will have another presentation which will actually explain more about the actual James Webb images and, how our new theories are developing around what we're seeing now. And it's quite a fascinating topic, really. So what we'll do is we'll just make a start. Let me just. Oh, I'm in the wrong place. Please talk amongst yourselves, people. Right, here we go. Right. So the dawn of the starlight, formation of the first stars after the Big Bang. So what we'll be doing. Let me just get. I've got a. Let me just hide this. What we'll be doing is exploring the cosmic dawn when the universe transitioned from darkness to light. and how the James Webb Telescope is revolutionizing our understanding of stellar genesis. The journey through time, our presentation, what we're actually going to be talking about, we'll just quickly through this. The Dark Ages, understanding the universe before the stars ignited, early theories, historical perspectives on population 3 star formation. Now, population 3 star formation, this is when they, in the 80s, I do believe it was, we'll find out later, they designated the different star groups, different populations, to put them in a sort of like a chronological list. So population 3 are the earliest stars that we believe actually existed. We'll be looking at theoretical evolution, how computational models refined our predictions. JWST revolution, the James Webb Space Telescope, new observations challenging existing paradigms, and current consensus, where the science stands today. So this is what we'll basically be flicking through. So here we are. The Cosmic Dark Ages, a universe without stars. So when, of course, just after the Big Bang, you had the primordial void. For approximately 100 million years after the Big Bang, the universe existed in complete darkness. Only hydrogen and helium and trace amounts of lithium filled the expanding cosmos. There were no stars, no galaxies, no light except the fading afterglow of the Big Bang itself. The cosmic microwave background, of course, which we know we've actually caught an image of, radiation cooling as space expanded. The conditions in the early universe. The temperatures was about 3,000 degrees Kelvin and falling rapidly at the beginning. Density far higher than today's universe. Composition 75% hydrogen and 25 helium. And the state neutral gas permeating all of space. So seeds of structure, quantum fluctuations. Tiny density variations from quantum fluctuations during inflation provided the gravitational seeds. These microscopic irregularities, and they were small, visible today in the cosmic microwave background. As I said, we've imaged it, and we can see these where these irregularities are, would eventually grow into the first stars and galaxies through gravitational collapse. And of course, we know that's where a clump of gases got together. It probably starts rotating, and then it pulls in more and more gas, gaining more and more mass, eventually creating the gravitational collapse. Right, early theoretical frameworks. Now this is through the 60s through to the 80s. This is so the 1960s. The initial concept. We're talking about people like Fred Hoyle and Roger Taylor, and that's not the drummer from Queen. Proposed that primordial stars must have formed from pure hydrogen and helium, fundamentally different from modern stars enriched with heavier elements. The 1970s, of course, is where I say astronomers categorize stars into populations. Population 3, purely hypothetical, and we've got to emphasize that at the moment, represented the first generation formed before any metals or elements heavier than helium existed in the universe. 1980s, mass predictions. Theorists predicted these primordial stars would be extremely massive, perhaps 100 to 1,000 times the mass of our sun, due to the absence of metal catalyzed cooling mechanisms. And we'll talk a little bit about that in a while. Now, this actually, I mean, considering what the new theories are, this 100 to 1,000 times the mass of our sun is well underestimated under the new theories. So here we are again. Population 2 stars couldn't be the oldest stars in the universe. The original stars were population 3 stars. These stars had masses from 30 to 1,000 mass of the sun. The depths of these stars provided matter incorporated into the next generation. So, of course, we're talking about in the cores of these, the nuclear cores of these suns, that all the new elements were being produced. So, of course, in here we have Fred Hoyle and Roger Taylor, who, through helio synthesis, we get the elements being produced in the cores and the atmospheres of suns. The metallicity problem. Why would the first stars be so massive? The answer lies in cooling physics. Modern stars form when gas clouds cool and contract. Heavy elements radiate energy efficiently, allowing smaller, cooler clumps to collapse. But the primordial universe lacked these elements. So what this is saying is, as we've gone through time, the stars have lived, died, and they produced all the elements. The elements actually provide a source of cooling for the primordial gases, the helium and stuff like that, which means they can then actually fragment and clump together and form smaller suns rather than big ones. But before the elements came into existence from the dying stars, then we had no cooling, and the helium and then the hydrogen was able to clump together and form absolutely gigantuan stars. And we'll talk about that in a little while. So the molecular hydrogen, the crucial coolant. Formation mechanism. Without metals, only molecular hydrogen, H2, could cool primordial gas clouds through rotation and vibrational transitions, enabling gravitational collapse. So that's just a posh way of all the is that the only form of cooling was from the hydrogen itself, and this was able to through the rotational. As it started to rotate, it started to pull in more and more gas, and we were able to start to build these massive, the beginning of these stars. Limited efficiency. H2 cooling was far less efficient than metal line cooling. So without the, of course, I forgot to mention when the elements are made and when we find them in the stars through spectroscopy, we call them metals. Anything higher than with a atomic weight higher than helium, we call it a metal. Requiring higher minimum temperatures of 200 degrees Kelvin and thus larger collapsing masses. So as I said, this is allowing it, because there's no metal, to actually also help cool the actual gases itself. These were able to form these really collapse into really massive stars. And then we got mass consequences. This inefficient cooling led theorists to predict the first stars would be supermassive, fundamentally unlike any stars we observe today. So again, we're talking about big stars. The computational revolution. So we're talking about the 1990s to the 2000s. Advanced computer simulations transformed our understanding. Tom Abel, Greg Bryan, and Michael Norman's landmark 202 simulation showed the first stars forming in dark matter halos, gravitational wells that concentrated primordial gas. These simulations predicted stars of 100 to 300 solar masses, with surface temperatures exceeding 100,000 Kelvin. Well, of course, this is just sort of we're using the predictions of what they had, all the data they had at the time. They were predicting that there could be this, that the dark matter was one of the predominant items in the after the Big Bang, and it was used. These were actually being turned into gravitational wells, which then started pulling the gas and then formed these massive stars. But as we said, we'll talk about that a bit later. So, key predictions from theoretical models. Extreme masses. First stars likely ranged from 100 to 1,000 sun masses, making them the most massive stars ever formed. Brief lifetimes, of course, if they're that big, they actually burn through their hydrogen a lot faster, their fuel, and they would have exhausted their fuel in just 2 to 3 million years. They would die in powerful explosions. The Dephis pairs in instability supernova, completely destroying the star and enriching space with the heavy elements. And I guess as we said, when the heavy elements became available, this started to cool the gas faster because the elements are able to radiate heat away, and this actually then meant that the gas could fragment, and then the stars that were forming were smaller and smaller, so to what we see today. Cosmic reionization, what's going to be put? Reionization. Their intense ultraviolet radiation would have ionized surrounding hydrogen, ending the dark ages. When did the first stars actually form? For decades, astronomers believed the cosmic dawn occurred around 200 to 400 million years after the Big Bang. But could we actually observe these ancient stellar populations? The James Webb Telescope, a new era, revolutionary capabilities. Launched in December 2021. Of course, it was actually on Christmas Day, and dinner was late that day because it launched around lunchtime. JWST's 6.5 meter mirror and infrared instruments can detect light from the universe's earliest epochs. By observing in the infrared spectrum, JWST bypasses the redshift that stretches ancient starlight into invisible wavelengths for optical telescopes. So James Webb's Space Telescope's shocking early discoveries. What we found is what we call LRDs, which are basically small. Sorry, what am I talking about? Small red dots. So when you look at these very deep field images, you can pick out, as you zoom in, you can pick out these very tiny red dots, like you can see in this two center images here. And the James Webb Telescope found galaxies too early and too massive. So what they were finding is that the galaxies were forming far earlier than we thought we predicted they should do, and they were far bigger than what we expected. So it detected massive, well-developed galaxies with redshifts of less than 10, less than 50 million years post Big 500 million years post Big Bang, far earlier and more massive than models predicted. And the impossible galaxy problem, some candidates appear to exist just 200 to 300 million years after the Big Bang, challenging our understanding of how quickly stars and galaxies could form. Spectroscopic confirmation that this is about the JADES program. The JADES GS Z13-0 confirmed at redshift Z13.2 this galaxy existed 325 million years after the Big Bang. Its spectrum reveals active star formation and surprisingly high metallicity. So even at this period in time, we were finding there was a lot of metal actually within this galaxy, in the dust and in the surrounding gases, which means that star formation must have happened far much earlier to supply this galaxy with the metallicity to start cooling down the gases to form more and more smaller stars and increasing the formation of these stars. These galaxies must have formed their first stars even earlier, perhaps as soon as 1 to 200 million years post Big Bang. As I just said, it's so these were producing elements a lot earlier. Chemical signatures tracing stellar populations. Enrichment patterns, unusual abundance ratios hint at pair instability supernova, the predicted death mode of first stars. Helium emission, strong helium-2 double ionized helium emission lines indicates extremely hot stars, which are about 50,000 K, consistent with massive population 3 stars. So again, we're talking about the first stars. They were very hot. Carbon enhanced metal poor stars observed may be direct descendants from first generation stellar nuclear synthesis. Poor metal stars, JWST, detected extreme metal poor galaxies and metallicity around 2% solar, suggesting recent population 3 star formation. Remember, this is looking and using spectroscopy to gauge what is actually within these galaxies and within these stars. Revised models, lower mass possibilities. Recent James Webb telescope observations have prompted theorists to reconsider not all first stars may have been supermassive behemoths. Binary fragmentation, collapsing gas clouds may have fragmented, producing multiple stars of varying masses, so 10 to 100 sun masses. So again, this is what it's saying is because we're finding the elements that have been enriched from dying stars and exploding stars. It's enabled cooling of the gas, and basically it means it can fragment and then basically form smaller stars. And we're saying that this has happened a lot earlier than we originally predicted. Hope that makes sense. Magnetic fields, primordial magnetic fields could have facilitated fragmentation, allowing smaller stars to form. Rotation effects, rapidly rotating gas clouds might form disk structures, spawning lower mass stellar companions. Now, the Sears survey, the Cosmic Evolution Early Release Science, SEERS, program revealed astonishing diversity in early galaxies. Some appear compact and dominated by younger massive stars, possibly population 3 remnants. Others show surprising structure, maturity, suggesting rapid evolution processes we don't yet fully understand. So this is still all theorized. So the current theoretical consensus, this is from 2024. Formation epoch. The first stars likely formed. Remember, we started off saying they were forming before around 400 to 500 million years after the Big Bang. But now we're thinking that they formed between 100 and 250 million years after the Big Bang. Mass range, diverse mass distribution possible. Some truly massive, 100 greater than 100 sun masses. Others more modest, about 10 to 50 sun masses through fragmentation. Rapid evolution, galaxy assembly occurred faster than models predicted, requiring efficient star formation mechanisms. So these galaxies were growing a lot faster, a lot sooner than we should really have been able to, than what we predicted. And chemical enrichment. Again, we come back to the first supernova. Novae quickly enriched the interstellar medium, enabling second generation population 2 stars, star formation within the 50 to 100 million, within the 50 and 100 million years. Outstanding questions in future research, direct detection. Can we actually see these? Be able to actually see these massive stars? Can we directly observe any individual population 3 stars? James Webb may detect them through gravitational lensing or magnification, or in extremely metal poor dwarf galaxies. Formation mechanisms. What determines the mass distribution? More important were how important were magnetic fields, turbulence, and radiative feedback in shaping first star characteristics. And what I mean by radiative feedback is that the elements, I mean, all mass, it will, if it's exposed to an intense radiation, it will warm up, and what it will then do is start to radiate the heat back, and so cause then this turbulence in the actual gas to actually form these smaller stars. Black hole seeds. Did some of the first stars collapse directly into black holes? This could explain the supermassive black holes JWST finds in very early galaxies. Now, there is another theory that some of these really massive, because what I'll be talking about next week is you'll find out how the new theories actually talk about these stars being a lot bigger than what we're talking about here, and that some of them could actually be fueled in the center by a black hole. But we'll talk about that next week. Cosmos Electricity of the first stars, architects of complexity. Every atom in our body heavier than hydrogen was forged in stellar furnaces. As we said, we are the stars. The first stars created the first carbon, oxygen, and iron, seeding the universe with the building blocks of the planets. And if you think about it, hydrogen was one of the first elements to actually be born after to exist after the Big Bang. And most of our body is made up of H2O. So those hydrogen atoms making up that water is 13.2 billion years old. They transformed a simple universe of hydrogen and helium into the chemical-rich cosmos we inhabit today. Conclusion: illuminating the cosmic dawn. Observational breakthroughs. The James Webb has pushed observations to within 300 million years of the Big Bang, revealing galaxies that challenge existing models. Theoretical refinement. Models now incorporate fragmentation, magnetic fields, and rapid chemical enrichment to explain observations. Future horizons. The quest to directly observe a population 3 star continues. The next decade promises revolutionary insight into our cosmic origins. Our understanding of the first star formation has evolved dramatically, from theoretical predictions to supermassive stellar monsters to James Webb's revelation of unexpectedly early diverse stellar populations. The cosmic dawn remains one of the astronomer's most captivating frontiers, where observation and theory converge to illuminate the universe's first light. The end. So
wow.
And next week we'll sort of like take it a little bit further.
Thank you very much.
Right.
Let me just get rid of that for you.
Yeah, please.
There we go.
Wonderful. Thank you so much for that, Daz. And you know, the James Webb has shown us in its 3 years of operations, 3 and a bit years, that we don't understand as much about the early universe as we thought we did. But just think of this: the James Webb, if all goes well, has got potentially another 17 years of life ahead of it. And just think what we're going to discover from the Webb within the next 17 years. It's truly mind-boggling. So thank you for that. That's absolutely excellent presentation.
That's fine. That's fine. You're welcome. And next week, hopefully, we'll just talk about what the James Webb has seen and how the new theories evolved. And it's a very fascinating, complex thing. I'll try and keep it simple, though. Yeah.
So there's so much to understand, and the fact that we pushed back the dates of the first stars by a couple of 100 million years, just with the data from the Webb, has demonstrated that there's still a lot we don't understand. Lots of people are saying, "Oh, the James Webb says the Big Bang didn't happen. The James Webb says that." No, it doesn't say any of that. What we thought we knew about the Big Bang and its aftermath still is solid as a rock. It's just that the fine detail in our models needs to be revised. But that's science for you. That is how science works. Okay, Shelley, I'll come back to you on that in a moment, if I may, because right now we're going to go over to, for those of you that are new here, and there seem to be quite a lot of you tonight, so we hope you're enjoying yourselves. And as I said, it's wonderful to have you here. Thank you for sharing your time with us. What we're going to do is go to a regular feature that we have here on Space Oddities called Einstein of the Week, where we take a light-hearted delve into the nether regions of social media to see what people are saying about the universe and related things. So if I can just get this up, I will do so. So here we go. Einstein of the week. Not many Einsteins of the week this week, but I hope you enjoy these nonetheless. Okay, Einstein of the week for this week. So the first one is, I've called this one, is Life, Jim, but not as we know it, because somebody wrote on social media this week, I don't think life started from chemistry. Which is an interesting take on things.
Yes.
Yeah. There has to be chemistry in there somewhere. Let's face it. There has to be chemistry in there somewhere. So, yes, I think I know what he was getting at, but we won't go into that.
Yeah. I mean, we could be in a chemical experiment that went wrong.
Yeah, absolutely.
You never know. You know,
Well,
lab experiment gone wrong.
You speak for yourself. So there just run that by me again. This is a little confusing. The moon doesn't rotate. The same side is always facing Earth. It used to rotate, causing 7-meter high waves of rock, but that force slowed the moon down until it eventually stopped, facing us forever. Because of this, it's slightly pear-shaped with the fat end facing Earth. Make that one what you will.
Right.
I don't know where people get these ideas, but weird. That's weird. So what are the markings on the moon? What are they? You tell me. What are the markings on the moon?
Well, most of them are lava fields or
exactly.
mare.
They are the mare. They're ancient volcanic plains of lava. Somebody thinks that they believe the markings to be a reflection of the Earth with its continents. To me, it even looks to show clouds in the reflection. So somebody thinks that the markings on the moon are a reflection of the Earth, which makes the Earth the moon one giant mirror, I guess, or something similar.
Something similar, yeah.
That's very, very strange. You know, if we use lasers to measure the Earth-Moon distance, firing them at the laser reflectors left on the moon by the Apollo astronauts. Of course, you know all that. But some other ideas. And thanks, Tom, for this. He gave me this one. When that laser is shot to measure the moon, it reflects and refracts off of the firmament, aka sky ice, hitting the Earth's surface, and call it a wildfire, climate change, driven cause like Lahaina. I'm not quite sure what that is. With fires that melt aluminium, 2,200 degrees F, but leave blue vinyl umbrellas intact. And the asphalt road, the melted cars are completely unaffected, even though asphalt melts at 600 degrees Fahrenheit. Direct energy weapon, NEXRAD, artificial ionospheric heaters, geoengineering, United Nations and WEF program for decades. We certainly have never left the closed system of the Earth.
Right. Okay. I think that's supposed to be the La Nina. That's the weather effect that he was talking about there.
Oh, right.
Yeah. But okay.
Yeah.
Yes. I mean, one of the things we did laugh at a couple of weeks back, if I remember, and there was one of these Einsteins, and it says the moon is actually within the Earth's atmosphere.
Yeah.
And of course, we said no, it's not. But it's actually now been proven that the moon is actually on the very outer limits of the Earth's atmosphere. So, but the rest of what they said on that,
don't encourage them. For God's sake, don't encourage them. So there we are. Anyway, that's all I've got for you this week on Einstein of the Week. There will be more, I'm sure, next week, because social media madness never stops, as we know. So there we are, Einstein of the Week for this week. Before we go any further, can I just bid all our new viewers a warm welcome from everybody at Space Oddities. We're a bit low, thin on the ground tonight because we've got Michael's ill, Lou's in Iceland, and I don't know where Tom is tonight. But if you come back next week, you might see the same faces. You might see completely different ones. Well, no, you won't. But no. But anyway, we're so glad you're here with us. And if you could just remember to like the video And if you could leave a comment as well after the show on the video, that would be great, because the YouTube algorithm actually looks at the number of comments and likes when it decides whether to recommend our videos to people. And if it doesn't see that many, then our videos don't get recommended and we get low viewing figures as a result. So if you could just remember to like, and also, of course, subscribe to the channel, completely free. Just click the subscribe button and turn the notification icon on so that you always know when we're either going live or publishing a new video. Don't forget, we've got 600 plus videos on the channel. There are playlists there you can have a wander through. And if you join the Patreon community, then of course you get access to a lot of videos as well, and presentations before we actually broadcast them. So you've got lots of reasons to join Patreon. And you've got lots of reasons to come back next week for more Space Oddities. I'm not quite sure what we'll be doing next week. Well, Daz will be doing the second part of his first stars, but we will have all the latest news and everything else, and no doubt some other juicy stuff as well. Okay, to finish off this evening, we're going to go to another weekly feature that we do. It's called Constellation of the Week, because guess what? It's Constellation of the Week. So I'm going to hand it over now to, yeah, you see the clues in the name. It does exactly what it says on the So nobody's ever suing us for misrepresentation. Constellation of the Week is Constellation of the Week. And to deliver this week's constellation, he's going to tell you all about it, is Roger.
Hello. Right. Well, I've only got 5 minutes or so from Derek's timer, so I better get on with it. Right, so we've got the constellation is Cancer, the crab in the night sky. Also one of the zodiacal signs, but we won't go there. Okay, so it's one of the dimmest of the zodiac constellations, but we won't go there. And it's located between Gemini and Leo, so it's a little bit of a treasure. So all well and good. And more information is about to follow. So in Greek mythology, Cancer was a valiant crab dispatched by the goddess Hera to distract the mighty Hercules during his legendary battle with the multi-headed Hydra. Although Hercules ultimately crushed the courageous crab beneath his foot, the goddess Hera honored its sacrifice by immortalizing it amongst the stars. We like a happy ending. So the powerful myth connects Cancer deeply to enduring themes of struggle, loyalty, and celestial immortality that have resonated through the millennia. So there we go. So we've got some very faint stars here, but nothing too much. Rough shaping of the crab there. We've got 5 main stars, which gives it an upside down Y shape. The brightest stars include Altarf, Delta Canceri, and Acubens, each contributing to the delicate pattern. And the 3 stars that form the bottom of the Y, representing the crab's arms. So we've got the most popular item from this one is M44. The beehive cluster, which is an open cluster.
Beautiful beehive.
Yes.
As beehives go, it has to be the best.
Absolutely. And it's approximately 577 light years away, with about 1,000 stars in the open cluster. So it's quite an easy object to look at. No, just needing some binoculars to be able to do it. And has been known since antiquity. And Ptolemy catalogued it as a remarkable cluster in the 2nd century. So the cluster is actually about 750 million years old, making them relatively young in the cosmic terms. So fairly young. But we've also got M67, another ancient star cluster. And this is nearly 3,000 light years away. But usually more easily observable with binoculars or a small telescope. So have a look at that if you've not seen that one either. So we've got some interesting K-type stars, Beta Canceri, Altrath. We've got accompanied on there with a faint red dwarf. So that's an interesting combination. Delta Canceri is the heart of the celestial crab. And then Alpha Canceri, which is known as Acubens, is a binary star system and is visible through the telescope quite easily. And we've also got exoplanetary systems through Cancer. Obviously, a lot of the constellations now are being rewarded with all these discoveries. And it's quite an interesting constellation, as we've also get some of the planets going through there as well. So it makes for some quite interesting photo opportunities. So normally, when Cancer is visible, it's between March, April, and May when it reaches its highest point, and that will be quite a good thing to see. And in the southern hemisphere, which we won't bother with, is obviously during the autumn, which is also during the same months. So we've got through the Tropic of Cancer. So that's when it reaches its summer solstice, approximately 2,000 years ago, and Cancer. So the axial precession that we've got of our wobble, it will be coming up here into Gemini during the summer solstice at some point. So good point for that. So we've got one of the constellations that we won't mention about the astrology.
We won't.
Although some people do like to talk about it, but there we are. So it's ruled by the moon and it's associated with the element of water.
Moving on.
And then we'll move on from there. But that's a brief rush through version due to the 10 o'clock time limit that Derek likes to set on us.
Yes.
So that's what we can say all about for this constellation for this week.
Thank you very much. So
okay.
Thank you, Roger. Next week it will be Michael's turn to deliver a very tiny constellation. And in fact, next week's constellation you couldn't get much smaller. So you'll have to tune in and find out which constellation that is. Perhaps you can already guess. Perhaps you know. But it's a very tiny constellation of the week next week. And because Michael likes doing the small ones and Roger likes doing the big ones. Make of that what you will. So there we are. All right, we are going to draw things to a close for this evening. Can I just remind you to like and subscribe, please, if you would be so kind. And don't forget the various ways you can support us by clicking the Super Chat icon and joining Patreon for just a few measly pounds every month. You get a whole load of stuff from us in terms of member benefits. We'd love to see you over there. We will be back next week at the same time, 8 o'clock UK. Thank you to everybody who has joined us for the first time tonight. And it's just wonderful to have so many of you out there. Thank you for all of your contributions in the chat as well. And we hope you'll join us again next week for more fun and frolics about the universe. So from Daz, from Roger and myself, we'd like to wish you a very peaceful, happy week. Stay safe, take care of each other, and we'll see you next week for more Space Oddities. And have a great weekend. I'm going to have a great time because it's my birthday on Monday. So I guess what I'll be doing. So
self-promotion.
okay, take care, everybody. Thanks for being here. We'll see you next week.